In section 7.7, we're going to set up some rational equations by reading problems. Our first one says for a recent year, the population of Alabama was approximately 4.2 million. At that time, Alabama had 7 representatives in the U.S. House of Representatives. In the same year, North Carolina had a population of about 7.2 million. If representation in the House is based on populations in equal proportions for each state, how many representatives did North Carolina have? So when you're talking about proportions in math, you're talking about equations where you have one fraction equals another fraction. And here what we're going to do is we're going to set up a fraction for each state. One fraction for Alabama, one fraction for North Carolina. And what we're going to do is we're going to put, we can put the population numbers on the top of the fraction, and we can put the number of representatives on the bottom of the fraction. So the population of Alabama, it says, was about 4.2 million, and they had 7 representatives in the House. The population of North Carolina was 7.2 million, and we don't know how many representatives they have. That's what we're trying to find. So we can put a variable for that, like R, or I often will just put X, just because it's the one I'm most familiar with. Now, when the equation that you have is a proportion, not like the ones we had in the previous section where you've got one fraction plus another one, or one fraction minus another one, when it's just one fraction on one side and one fraction on the other side, the shortcut method for solving it is to take what's called the cross products and set them equal to each other. Here, our first cross product, the top of one times the bottom of the other one, is 4.2 times x, which gives us 4.2x. Our other cross product is 7 times 7.2, and that gives us 50.4. And now this equation is much easier to solve. We finish by dividing both sides by 4.2, and we end up with x equals 12. So North Carolina would have 12 representatives in that situation. Let's take a look at our next problem. Here it says, see the skills practice at the bottom of page 537. So let's take a look in our books at the bottom of page 537. Lost it there. Here we go. Here it says, triangle ABC is similar to triangle XYZ. Solve for the lengths of the missing sides. Similar in geometry is another way of saying that the sides are in proportion to each other. So our first triangle, we have sides of 12, 16, and 4. The next triangle is the same angles but smaller, and it has sides of y and 6 and x. So first, let's do, we can pick either variable to find first. Suppose we want to first find x. So we need to set up a proportion that has x in it. And what I would do is take x for the top of my fraction, and then the only other number I know in that triangle is 6. So I'm going to do x over 6. So notice, since I did the bottom side divided by the right side for that fraction, when I use my other fraction for the other triangle, I have to do it the same way. The bottom side divided by the right side. So here I have x over 6 equals 4 over 16, like that. There are other ways you could set this up, but that's just one way you could set up that one. And then we solve by cross multiplying. X times 6 is 16x. 6 times 4 is 24. We finish by dividing both sides by 16. 24 over 16, when you reduce it, divide them both by 8, you get 3 halves, like that. Oh, and I just noticed that this problem in the textbook does give units of inches. for all of the sides. So we would need to say 3/2 inches for x. Now let's do something similar to find y. When we're finding y, we want to make sure one of our fractions has y in it. So this time, instead of the bottom side divided by the right side, we'll do the left side divided by the right side, y over 6. And if we do our fraction for that triangle, for the other triangle, we have to follow the same order. Left side of 12 over the right side of 16. So now our cross products, we have y times 16, which is 16y. 6 times 12, which is 72. Then we divide both sides by 16. And we would have y equals, let's see, if we divide both of those are both divisible by 8. We would get 9/2 inches for y. So the problems on this page, we were able to set up proportions where we just have one fraction equals one fraction. And those are quick to solve by using what we call cross products. Let's take a look at the next page. It says the sun casts a 3.2-foot shadow of a 6-foot man. At the same time, the sun casts an 80-foot shadow of a building. How tall is the building? So, shadows create proportional shapes, assuming you're at the same time in approximately the same place. So, for example, let's say we've got our sun up here shining down on some people. And here's my amazing artistic skills on display. The man, who is 6 feet tall, creates a 3.2-foot shadow. Then we have a building, and the sun's rays are shining down there. The building has a shadow of 80 feet. And what we're trying to do is figure out how tall the building is. So I'll call that I'll call it h for height. This, by the way, is a way you can get pretty accurate measurements of things like a tree next to your house. If you can find a sunny day, you can measure your height and your shadow, measure the shadow of the tree, and do this to figure out pretty accurately how tall the tree is. So here, we've got similar figures again. So we're going to set up a proportion. And here, I'm going to put the heights on top, shadows on the bottom. You could do shadow on top, height on the bottom, it wouldn't matter, as long as the way you set up the first fraction corresponds to the way you set up the second one. So for the person, the height is 6 and the shadow is 3.2. For the building, we don't know the height, so I put h for that, and the shadow was 80 feet. Now we can use our cross products to finish the problem. 6 times 80 is 480. 3.2 times h is 3.2h. Divide both sides by 3.2 to finish it. Oh, better use my calculator so I don't make a mental mistake. 480 divided by 3.2, we get 150 equals h. And we do need units. It looks like our units for this problem are feet. So the building would be 150 feet tall. People have been using this method for thousands of years to measure heights of natural things, even things such as mountains. People have measured heights of mountains pretty accurately this way. All right, so let's take a look at another one. Here it says, a small plane flies 440 miles with the wind from Memphis to Oklahoma City. In the same amount of time, that's spelled wrong. The plane flies 340 miles against the wind from Oklahoma City to Little Rock. If the wind speed is 30 miles per hour, find the speed of the plane in still air. All right, so when you get one of these plane problems where it's with or against the wind, or a boat problem going with or against the current, and it says you've got something where they travel the same amount of time. The way these formulas work, you have rate multiplied by time equals distance. And if you divide both sides of that by r, you get time equals distance divided by rate. So anytime you've got one of these same time problems, the way you're going to set it up is you're going to have one fraction representing the time for the first part, which is the distance for the first part divided by the rate for the first part. And you're going to have equal to another fraction that is the distance for the second part divided by the rate for the second part. And in the case of this problem, we're going to have one fraction representing what happens when you're traveling with the wind, and a second fraction showing what happens when we're traveling against the wind. All right. So for the first part, traveling with the wind, it flies 440 miles. So we'll put that for our distance. Remember, we're doing distance divided by rate for these fractions. So our distance with the wind is 440 miles. In the same time, it travels 340 miles against the wind. So the against the wind distance would be 340. Now it says here the wind speed is 300, and we want to find the speed of the plane in still air. We don't know what the speed of the plane in still air is, so we're going to call that x. And when you're traveling with the wind, you take the speed in still air and you add the wind speed. When you're traveling against the wind, you take the speed in still air and we subtract our wind speed. So here, in this case, our speed with the wind is x plus 30. Our speed against the wind is x minus 30. Now, we've got another proportion here, so we can do cross products. And just be careful that when you're doing cross products, for example, for 440 times x minus 30, you have to distribute. You have to multiply that 440 by both parts of that. So 440 times x is 440x. And then 440 times minus 30, we have minus 13,200. On the other side, x times 340 is 340x. And 30 times 340, we have 10,200. All right, so now to solve this, I would subtract 340x from both sides and add 13,200 to both sides. And we end up with 100x equals, let's see, that's 23,400. Oh, this one I can solve in my head. Divide both sides by 100 and we get x equals 234. Now, thinking about units, what we just found was x, which is the speed of the plane in still air. For this problem, our speed units are miles per hour. So we'd finish this by making it 234 miles per hour, like so. All right, let's try one more of these problems. It says, Al and Mario operate a small roofing company. Mario can roof an average house alone in 9 hours. Al can roof a house alone in 8 hours. How long will it take them to do the job if they work together? So these sort of working together problems have a particular way you set them up. You take the fraction of the job that one person could complete in an hour, which is 1 divided by the time for the first person. Oh, let's just put that's looking messy. Let's do this. Time 1. Plus the fraction of the job the second person could complete in an hour. So that's 1 divided by the time for person number 2. And that's going to be equal to 1 divided by the time it would take if they're working together. Basically, what this equation represents is the part of the job the first person could do by themselves plus the part of the job the second person could do by themselves is equal to the part of the job they could complete together. All right, so thinking of this particular problem, it says Mario can roof the house alone in 9 hours. So the time for the first person by themselves is 9 hours. I'm going to leave a little bit of space in front of that next fraction because I know what we're going to do with it in a minute. The next person can do the job by themselves in 8 hours. Now, we don't know how long it's going to take them to work together, so I'm going to put X for that. So here we can't do cross products for this one because we don't have one fraction equals one fraction. So we're going to go back to our other method of getting rid of the denominators by multiplying everything by a common denominator. Now here, our common denominator is going to be 9 times 8 times x. So we have 9 times 8 times x times the first fraction plus 9 times 8 times x for the next fraction equals 9 times 8 times x for the last fraction. On the first one, the 9 and 9 cancel out, and 8 times x times 1 is 8x. The next fraction, the 8's cancel out. 9 times x times 1 is 9x. And then the last fraction, 9 times 8, after the x's cancel out, 9 times 8 times 1 is 72. So we have 17x equals 72. Divide both sides by 17, and we have x equals 72 over 17. And we're finding a time here. X is representing time, and our units for time on this problem would be hours.